This is the reason Iran's exclusion from the global arms market forced a decade-long engineering pivot to create the Bavar-373 long-range surface-to-air missile defense system. Denied the Russian S-300 in 2010, Iranian engineers developed a domestic platform that now claims to rival the world's most advanced interceptors. The conceptualization of the Bavar-373 represents a watershed moment in the Islamic Republic of Iran's military-industrial history, and the system's genesis sits firmly in a period of severe diplomatic isolation. Back in 2007, the Iranian government sought to modernize its air defense network by signing a contract with the Russian Federation for 5 batteries of the S-300 PMU-1 system. This contract involved hundreds of millions of dollars because the government needed a high-altitude shield for its industrial and nuclear sites, which then relied on legacy American systems like the MIM-23 Hawk and older Soviet platforms. Geopolitical shifts in 2010 changed everything for the Iranian defense establishment. Following United Nations Security Council sanctions, then Russian President Dmitry Medvedev issued a decree freezing the sale and delivery of the S-300. This decision left Iranian defense planners with a critical vulnerability at a time of rising regional tensions and immediate threats of aerial strikes. Supreme Leader Ayatollah Khamenei issued a direct mandate to the Ministry of Defense and Armed Forces Logistics to develop an indigenous long-range air defense system. The order was to match the capabilities of the Russian S-300 while improving upon its design by leveraging local engineering and avoiding the specific weak points identified during Iranian personnel training in Russia. Iranian officials designated the new project Bavar-373 to signify the nation's confidence in its domestic scientific capabilities. The word Bavar translates to belief, and the numeral 373 corresponds to the phrase Ya Rasulullah in the Abjad system of numerology. By November 2011, the first prototype sat on the factory floor for initial inspection. Development reached 30% completion by September 2012, and laboratory testing of critical guidance and radar subsystems followed in 2013. Although the successful delivery of Russian S-300 PMU-2 batteries finally occurred in 2016. After the lifting of sanctions, the Bavar program continued as a domestic benchmark for Iranian engineers under the oversight of the Khatam al-Anbia air defense base. The Bavar-373 functions as a road-mobile air defense asset designed to survive suppression of enemy air defenses, often called SEAD operations. 2 primary vehicle platforms form the backbone of every battery. The first is the Zafar 8x8 heavy truck, and this 8-wheeled vehicle transports the system's primary radar complexes and command and control posts while using a 400-horsepower turbocharged diesel engine. This truck carries up to 24 tons of high-tech equipment across varied Iranian topography. The second platform is the Zol-Jannah, a massive 10x10 carrier truck designed for the transporter erector launchers. The Zol-Jannah carries up to 30 tons and can ford water bodies up to 1.5 meters deep, allowing the launchers to hide in rugged terrain or move between prepared revetments to evade counterstrikes. Each Zol-Jannah carrier typically carries 4 rectangular launch canisters that utilize a hot launch vertical system. Unlike the Russian S-300's cold launch method, where a gas generator ejects the missile before ignition, the Bavar-373 ignites the rocket motor while it is still inside the canister. While this requires more robust canister materials to withstand the heat and pressure, it allows for a simpler mechanical design and a much faster rate of fire. The vertical orientation ensures 360-degree coverage, which means the battery can engage targets in any direction without the delay of rotating the launcher toward the threat. The operational heart of the system is its sophisticated radar suite, and the engineers used active electronically scanned array technology to detect targets with extremely low radar cross-sections. The primary acquisition sensor is the Mirage 4, a long-range 3D AESA radar operating in the S-band. Following optimizations in 2022, the Mirage 4 can detect targets at ranges of up to 450 kilometers and track them at ranges of 405 kilometers. The radar monitors up to 300 targets simultaneously, providing a comprehensive picture of the battle space to the command center. Complementing the Mirage 4 is the Najm 804 engagement radar, and this sensor typically operates in the X-band to provide the high precision required for missile guidance. The Najm 804 is designed to withstand intense electronic warfare and electromagnetic bombs using advanced electronic countermeasures. These features include frequency hopping, side lobe blanking, and jamming analysis transmission selection, which allow the system to burn through enemy jamming signals and maintain a lock. To counter fifth-generation stealth fighters like the F-35 I, Iran also integrates the al-Anbia passive detection system. Passive radars analyze how ambient electromagnetic energy, like radio, television, or cellular signals, reflects off stealthy airframes without emitting signals of their own. The system's kinetic performance relies on the Sayyad family of solid-fuel interceptors, and these missiles have evolved from reverse-engineered American hardware to entirely indigenous designs. The Sayyad 4 missile is roughly 7.5 meters long and weighs 2,050 kilograms. It carries a 180-kilogram high-explosive fragmentation warhead and reaches speeds between Mach 6 and Mach 8. The missile's development drew from analysis of the Russian 48N-6E missile used in the S-300 system, allowing Iranian engineers to optimize performance parameters for their specific operational requirements. In November 2022, the introduction of the Sayyad 4B significantly extended the engagement envelope by increasing the range to over 300 kilometers. During a publicized test, the missile successfully intercepted a drone target at an altitude of 32 kilometers, which is roughly 105,000 feet. Advanced variants of these missiles incorporate thrust vector control, and this technology allows the missile to maneuver using engine exhaust nozzles rather than purely aerodynamic fins. This is vital for high-altitude intercepts where the air is too thin for traditional fins to be effective. Combined with proximity fuses, the high-velocity shrapnel from the warhead ensures that even a near miss can result in the destruction of the target. The system uses a mix of inertial mid-course guidance and active radar homing for the final engagement phase. In February 2025, Iran unveiled the Bavar-373 II to address the vulnerability of centralized command and control architectures. In a standard battery, individual launchers depend on a central engagement radar. And if an anti-radiation missile or electronic warfare strike destroys that central radar, the entire battery is neutralized. The Bavar-373 II shifts to autonomous TELAR units, which stands for Transporter Erector Launcher and Radar. Each launcher vehicle is equipped with its own dedicated radar array mounted on a mechanical arm, and this allows the units to search for and engage targets independently even if the central command link is severed. The Bavar-373 II can now simultaneously engage 9 targets, which is an improvement over the 6 targets managed by the original version and the Russian S-300. These upgraded radar units are reportedly capable of maintaining surveillance while the vehicle is in motion, significantly reducing the time needed to set up and fire. This transition to decentralized technology reflects a survivalist defense posture intended to protect strategic nuclear sites at Natanz and Isfahan, where the Bavar-373 operates alongside complementary systems like the shorter-range Khordad-15 air defense system. In a conflict where an adversary uses advanced SAD assets, a network of autonomous launchers is far more difficult to suppress than a traditional centralized battery. Technical comparisons with foreign systems show that the Bavar-373 is a competitive platform in its specific class. The Russian S-400 Triumph remains the world's leading system with a detection range of 600 kilometers and the ability to engage 80 targets simultaneously. The Bavar tracks fewer targets, but its engagement range of over 300 kilometers with the Sayyad 4B is superior to the older S-300PMU-2 and most variants of the American Patriot. A critical technical distinction lies in the interception logic, as the American Patriot PAC-3 MSE utilizes hit-to-kill technology while the Bavar-373 generally relies on blast fragmentation warheads that explode near the target. While hit-to-kill is superior for destroying chemical or nuclear warheads through pure kinetic energy, blast fragmentation is highly effective against aerodynamic targets like fighters and drones. Iran's inclusion of infrared guidance in the final phase of the Bavar-373 II adds a layer of redundancy against stealth targets that might evade radar. Military analysts note that while the system stands up better to visual scrutiny than previous projects, its effectiveness against the most cutting-edge Western platforms remains a subject of debate. The deployment of these systems forces adversaries to rely on limited-resource stealth aircraft and standoff munitions. The theoretical capabilities of the Bavar-373 were subjected to a catastrophic real-world test in June 2025 during the conflict known as Operation Rising Lion. This 12-day war involved massive airstrikes against Iran's nuclear complexes and air defense infrastructure. During the opening hours, approximately 200 Israeli fighter jets executed 5 waves of strikes, and these attacks killed several top Iranian military leaders, including IRGC Chief Hossein Salami and Aerospace Commander Amir Ali Hajizadeh. The strikes targeted the air defense network specifically to create a radar gap that would allow heavy bombers to reach the Natanz and Isfahan facilities. Despite the severity of the campaign, the Bavar-373 achieved notable engagement successes by tracking and engaging offensive drones at distances of over 300 kilometers. Some independent analysts assess that the reputation of the system as an F-35 killer might have contributed to the modification of certain high-risk strikes when radar locks were achieved at a distance. However, the conflict also highlighted the limits of Iran's defenses, and by the end of the 12 days, the inventory of mobile air defense launchers had dropped to a critical low. Iran fired over 500 ballistic missiles and a significant portion of its surface-to-air interceptors during the war. Precision strikes during Operation Rising Lion destroyed between 12 and 20 planetary mixers used to produce solid fuel for the Sayyad and ballistic missiles. This damage crippled Iran's ability to rapidly replenish its arsenal and paralyzed the production of solid fuel missiles like the Sejil and Fateh 1. The conflict demonstrated that while a system like the Bavar-373 can make an aerial campaign more difficult and time-consuming, it cannot provide an absolute shield against a full-scale saturation attack by a modern air force. By late June 2025, the Israeli Air Force claimed to have established full aerial superiority over Iranian skies. As of February 2026, Iran is engaged in a massive race to rebuild its air defense and nuclear array through a differential reconstruction doctrine. This rebuilding effort prioritizes the fortification of the most sensitive assets while maintaining a public-facing stance of diplomatic openness. Satellite imagery from Planet Labs and Airbus shows surviving S-300 and Bavar-373 launchers returning to sites near Tehran, such as Karizak and Kavar Shar. Analysts note that these sites are using a hybrid layering strategy that links surviving Russian hardware with the new Bavar-373 II autonomous radar sets to complicate strike planning. To compensate for the losses of ground-based batteries, Russia is expected to deliver 48 Su-35 fighter jets to Iran. These fourth-generation plus aircraft are intended to work in tandem with the Bavar-373 to provide an aerial layer to the defense network. Simultaneously, Iran is accelerating the construction of a new nuclear-related facility south of Natanz known as Pickaxe Mountain. This facility is being dug to depths of 80 to 100 meters in hard granite rock, specifically to resist the American GBU-57 bunker buster bombs carried by B-2 Spirit bombers. Tunnel entrances at Isfahan and Natanz are also being buried under massive concrete sarcophagi and reinforced with missile chicanes to block direct penetration by cruise missiles. These protective walls are designed to shield the sites from future strikes and prevent surprise inspections by international watchdogs. The reappearance of these defensive systems just 9 months after Operation Midnight Hammer serves as a signal that the Iranian integrated air defense system retains operational continuity despite heavy losses. Rebuilding these defenses is a strategic catalyst for the reconstruction of the nation's entire military infrastructure. Beyond domestic defense, Iran has actively sought to turn the Bavar-373 into a source of foreign revenue and regional influence. The system is marketed internationally under the designation AD-200, and it was displayed at the Dimdex 2022 exhibition in Doha. The AD-200 offers a detection range of 260 kilometers and an engagement range of 200 kilometers for aircraft, drones, and cruise missiles. Shorter-range variants like the AD-40 are also marketed for handling tactical aerial threats with a 40-kilometer engagement range. The strategic appeal of the AD-200 for countries in Africa and South America is twofold. First, it is significantly more affordable than the S-400 or the Patriot, which can cost upwards of $700 million per battery. Second, Iran provides full access to software codes and secure network protocols, which is a major selling point for nations wary of the kill switches or surveillance backdoors often attributed to Western military technology. Successful exports could boost Iran's foreign revenue and soft power while decreasing its reliance on East or West for technology. If Iran succeeds in deploying these systems to its regional proxies in Lebanon, Syria, Iraq, or Yemen, it would create an air defense axis that could fundamentally challenge the aerial supremacy of Western forces. This proliferation strategy acts as a deterrent by making any regional intervention far more costly and risky for the United States and its allies. The presence of these systems near foreign bases increases the need for robust air defense that does not rely on foreign suppliers. Bavar-373 symbolizes this strategic direction toward indigenous development and self-sufficiency in defense technology. The history and current status of the Bavar-373 reflect the enduring paradox of Iran's military posture. It is a nation that has achieved remarkable technological milestones under extreme pressure, yet it remains vulnerable to the overwhelming mass of advanced Western air power. The transition from the basic Sayed II to the Mach 8 plus Sayed 4B demonstrates a highly adaptive engineering culture that responds to evolving threats. With its 300-kilometer engagement range and 32-kilometer altitude capability, this platform remains a cornerstone of Iran's strategy to protect its strategic infrastructure and project power in a volatile region. The 12-day war of 2025 provided the ultimate stress test for these systems, proving that they can strike fear into fighter pilots but cannot survive a prolonged campaign without a robust industrial base to replenish losses. However, the speed of Iran's 2026 reconstruction efforts suggests that the belief in indigenous air sovereignty is not easily extinguished. As Iran integrates Su-35s into its network and builds deeper underground facilities, the Bavar-373 will remain the primary barrier to any attempt at a surgical strike against its core strategic interests. The technical evolution of this system is not just a matter of aerospace engineering, but a fundamental component of Iran's long-term survival strategy.